Hi guys, this is my latest project, an ATmega 328 based volt logger. The main goal of this project for me is to learn. I just want to learn more. And having something to use in the end is a bonus. I'm new with IDE design, so the design is actually very basic. I'm posting this video so some of you may be able to learn from what I've learned, and hopefully some of you will make comments that I can learn from also. I plan to divide this video into 3 or 4 segments. This particular introduction, going through the features, and then showing how it works, how accurate it is or not, going through the circuits, and then the last segment we will go into the mistake I've made and things that I would have done different. In hindsight, there are some mistakes. So here it is. I call this my DinoMeter. Because it is for logging, I plan to use this with one of my dinosaur laptops so I don't tie up my main machine. So using with dinosaur laptops, I call this my DinoMeter. It has 4 independent channels. They all share a common ground, but each channel has 7 ranges. They can all be at different ranges. I'm going to zoom in. The multiplier is at -1. On negative, the divider doesn't function, just the multiplier, and it's being done in inverting multiplication mode. So the range is a -5 volt range. -24. -24 is a 0.2 volt range, so there's 200 millivolt negative. Now we go into the positive. Positive 25 multiplier plus 0.2 volt. (2x) multiplier 2.5 volt, 5 volt. Divide by 3, that's my 15 volt. And divide by 6, that's my 30 volt max. You can see that I have a power on off. These are the channel inputs. They are pin headers. Initially I have alligator clip and I didn't like how that worked. Since I'm more often using this with breadboard, I decided to put on pin headers. 2 positives and 1 ground. We will get into how the keypad works. The keypad is for setting up special options, such as pairing 2 channels to measure wattage. The 2.5 volt, particularly the 0.2 volt, the 200 millivolt, are designed to measure the voltage across a 0.1 ohm shunt or 1 ohm shunt, so we can measure current that way, and pairing them we can calculate the wattage. Okay, the next part, we're going to hook this up and see how this works in more or less a real life situation. I'm not going to use this to just measure a battery, that's too plain. I'm going to use this to measure a boost buck board, the amount of wattage input and the amount of wattage output, watt, W-A-T-T, not volt. So I'm going to hook up the circuit this way and then start showing how that board works. So the output from the power supply go into this boost board. This guy is below common ground. Green is the common ground, and green goes to the common ground of this guy. The output positive goes to this LED light, and the LED return path goes through this shunt. This is also a 0.1 ohm shunt, and go back to common ground. The white wire measure this voltage, this white wire, which I loop around and go into channel 3. So this white wire go to channel 3, measuring this output. The yellow wire here measures this shunt, this 0.1 ohm shunt. on the low side. On the supply side, this 0.1 ohm shunt through the yellow wire is connected to channel 0. So this connects to channel 0. And the white wire here measure the voltage that goes into the boost buck board. So let's see how well it does. I'm going to turn it on and connect this to the common ground and move things a little closer, as close as we can anyway. Right now it says that the input shunt, which is below ground, is at 20.8 millivolt. Let's take a look. It's actually 19.91 millivolt. What is measured here is 20.4. So 19.95, 20 and change is certainly very close, very close. Oh, I actually have the polarity reverse here. Let's switch the polarity. That's ground. Polarity of this guy is now minus 20, and this guy is minus 20. Next one. The voltage in. The voltage in the unity says 7.238 volt. 7.213. So it is close, but not exact. 7.21 versus 7.23. The voltage to the LED plus this shunt is 9.575, 9.566. So close, very close. The voltage across this shunt, the unity says 1.21 millivolt. This guy says 1.2 millivolt, 1.21 millivolt, so very close. Well, in fact, I call it spot on. Now, let's see the other feature. I'm going to use this keypad to set up the feature, but in order to be able to use the keypad, I'm going to center this a little bit and zoom in. Starting at the top, 22.1 millivolt. It really is about 200 milliamp because it is a 0.1 ohm shunt. So I want this to show milliamp, and I'll go into channel 0. The unit will be changed to 1 millivolt equal 10 milliamp. So it's volt. 1 millivolt equal 1 milliamp. 1 millivolt equal 10. So now I can see the current as it is. On channel 1, which measure the voltage, I'm going to pair it and calculate the wattage. The A there means the exact ADC reading, averaged out over about 200 readings. So there's a floating point number, which actually helped me with accuracy. This guy is one. Now that we have dealt with the first pair, let's deal with the second pair, channel 2 and 3. On channel 2, I'm going to do the same thing. And change this to 1 millivolt equal 10 milliamp. So now that's showing me 12.1 milliamp out. At 1.24 millivolt for that shunt, 0.1 ohm shunt, that should be 12.4. This says 12.1, almost spot on. on this voltage, remember I need to subtract off this guy to get this guy. So I need to subtract this voltage off this guy to get the exact voltage across the load. The voltage on this guy on channel 2 is actually 1.2 millivolt, which is of course right. That's why it is 12 milliamp. And I want that to subtract off the last one. The voltage before subtraction, this little V here tell me the voltage before subtraction is 9.567. After subtraction is 9.565. So you can see that the subtraction did occur. Now on this, I'm going to show the wattage, W, ATT. So at an input of, moving this around is causing it to disconnect. Plugging it back in. Come on. It is 1.5 watt in and 0.11 watt out. Lousy, is it? Efficiency isn't that great on this little boost buck board, but that's not the point. The point is to show how I can measure both of them, and they match up with the unity quite nicely.